Howdy, AP Pre-Cal. It is Miss Kosh. Today it is a Friday afternoon after a full week of AP and IB testing, and I am exhausted. But I'm going to try and work through the FRQ problems for you on video. I have not looked at them, and I can't share the actual problem with you because they're copyrighted by College Board, and I don't want to do that. So I will. They're over here in my site, but not in yours. And so you'll see what I write down, and you'll see my calculator screen, and we're going to go with that. So I started with a cleared calculator, and this first FRQ1 starts with a table of F values and a function for G. So I'm going to come in and I'm going to type in that function. So negative, what is this, 0.167x cubed plus x squared. By the way, Desmos is great too. Yeah, you'll have to let me know how you liked using Desmos. Okay, so the first question says the function h is defined, this is how they like to do these. H is equal to g of f of x. And so they want us to find h of 1. So h of 1, by the way, I'm going to go, I've been I've been approved to, or I was selected to be one of the graders this summer. So I may come back and redo these videos telling you now that I have been a grader, I know exactly what they're looking for. But in the meantime, I know a lot, so hopefully it's good enough. Okay, so h of 1 means, what did I write? Y'all, this is not going to go well. Okay, I'm tired. This notation is wrong. H of x is equal to g of f of x. My apologies. There we go. Okay, so h of 1 would be g of f of 1. And so when I look at my table, I see that f of 1 is 1.75. And so now I need to figure out what is g of this. And so I typed that equation in already. Well, okay, so I can do G solve, come over, find the y cal when my x value is 1.75. This is not the only way to do this problem, but it is one way. Show the work that leads to your answer. Okay, this to me seems like work, but then I would say it's approximately 0.3335. One of my colleagues in the past suggested going to 4 decimal places because you can either truncate or round to 3. And so if I round this incorrectly, I'm still okay because then it would be truncated. So I think that would be enough for the first question. Okay, so find the value of, so then they want f to the negative 1 of 3.5, so the inverse, so this is saying that f was the table, which you can't see, but this is saying the inverse would equal, well, some value k. This would be like saying f of k is equal to 3.5. So this, what is the input value here of the inverse becomes the output value of the function. And so the output value of 3.5 gives us an input value of x equals 0. So, or maybe we should say f to the negative 1 of 3.5 is equal to 0. That's how I would write that. Okay, the next one, find all values of x as decimal approximations for which g of x equals 0. Okay, so that's why we typed this in our calculator. Can you see it? Oh, now you can. Okay, so I can do g solve root and find 1. Okay, so the first one here, so this was, okay, here's my next problem. I have that x is approximately, oh, you lost the ability to see what I'm doing, 1.2332, and then I come over here, and I get that x is approximately 1.5781. And I get another one over here, that x is approximately 5.6432. Okay, and so that is what I would write for those. On these, notice, okay, so what I would think about too, remember, this is a cubic function. And so a cubic function can have as many as 3 zeros. Our window was kind of, I like this standard, oh, I didn't even do a standard, but I like that standard window. And so you can see clearly, okay, it could have 3 zeros. It had 3 zeros. We found all of them. But if it had zoomed in just on part of it, you should think back to what type of function is it? How many zeros might we have? Okay, the next one is determine the end behavior as g increases without bound. So the limit as x goes to increases means positive infinity of g of x equals, well, when I look at this graph, as it increases, it's going to decrease. And so I would say negative infinity. And that's mathematical notation of a limit, and there we go. Based on the table, which of the following function type best model a function of f? Linear, quadratic, exponential, or logarithmic? Okay, so the input values are changing by 1. So it goes -2, -1, 0, 1, 2. And then I see 14, 7. Okay, so 14, half of 14 is 7, half of 7 is 3.5, half of 1.75. So it looks to me like it's an exponential function because it's got the growth factor is actually a decay factor of 1/2. So if it were a geometric sequence, we would say that the R value, the common ratio is 1/2. Okay, give a reason for my answer based on the relationship between the change in the output values of f and the change in the input values of f. Refer to the values of in the table for your reasoning. I'm not going to write anything, but you should say something about the input values change at a constant rate. We go -1, -2, -1, 0, 1, 2. We have a constant rate of change of 1 in the input values. The export, I'm tired, I'm sorry. I don't even know what word I came up with. The output values are, the rate of change of the output values has a common ratio. Is that what we want to say? The output values are changing with a common ratio, with a constant ratio. So they have and that constant ratio is 1/2. And maybe say something about how 14 goes to 7, and half of 7 is 3.5, and half of that, and something like that. So use the values of in the table and that sort of thing. Okay, that was FRQ 1. You would need to write a little bit more than I wrote, but I'm not showing you the paper on purpose. Okay, so let us continue with FRQ 2. Okay, it tells us a musician released a new song on a streaming service. Okay. Oh, and this one's quadratic. At t equals 0. Okay, so I'm sorry, I'm not reading all of it, but they want us to use the function d of t is equal to at squared plus bt plus c. And so what we have is we know that d of 0 is going to be equal to a times 0 squared plus b times 0 plus c. And the output value for an input value of 0. Okay, notice I have not looked at these problems at all. I did not read all of this. Maybe I should read a little bit more. Several months later, the musician begins using an app at time t equals 0 that counts the total number of plays for a song. A play is a single stream of the song. The table gives the total number of plays in thousands for selected times t months after. At t equals either total number of plays was 25,000. At t equals 2, it was 30,000. Okay. At t equals 4, the total number of plays in thousands for the song that was released. Okay, so they said the total number of play in thousands, so I'm keeping this at just 25 and not 25,000. I will be curious this summer whether or not they will accept an answer of 25,000 with 3 zeros. The way I interpret this now is they're telling you not to. They're saying in thousands. How many thousands is this? It's 25,000. 25,000. Thousands? My apologies. Okay. Then the next one, so then it says use the given data to write 3 equations. Okay, so here's the first one. The next one, d of 2 would be equal to a times 2 squared plus b times 2 plus c, and that output value was 30. And then d of 4 is equal to a times 4 squared plus b times 4 plus c, and that is equal to 34. That was the output value for that one. Me personally, I think we have answered what they asked for, but maybe we could clean this up. This would imply this first one 0, 0, so that c is equal to 25, and then I see let me line it up, 4a plus 2b, I didn't line it up very well, plus c is equal to 30, and then I have a 16a plus 4b plus c is equal to 34. And so it just says find the values of a, b, and c as decimal approximations. It doesn't tell us how to do it. So what I would do is I would come to my calculator and go to equation, and it's a simultaneous. We have 3 unknowns, and so it's 0, 0, 1, hang on, 0, 0, 1, 25. Can you see where I'm seeing this from? Okay, and then I see 4, and I see 2, and I see 1, and I see 30. I see 16, 4, 1, 34. Okay, so this first one, they're saying as decimal approximations. I think this is the difference between AP and IB. AP would say leave it as an exact value or 3 sig figs. AP right here is saying as decimal approximations. So what I find is that our first value, A, is equal to negative 0.125. And that isn't, it's not an approximation because that is the exact value, but they want three decimal places, so there we go. I think that we need to write it as a decimal. And this one should be 2.75. Me personally, I would not say as decimal approximations. I would say find the exact value because they were exact values. I'll know after we grade this summer if they think these are approximations or exact values. But anyway, that's the right answer. We wrote them as decimals. I mean, maybe we should write this and get 3 decimals everywhere. Okay, this will be something I may try and, will I remember this at the end of June? I don't know, but anyway, ask me, comment below next school year if I remember to find out about that at the AP grading. Okay, so it says, use the given data to find the average rate of change of the total number of plays for the song in thousands a month from T equals, okay, so the average rate of change so it's going to be D of, they went from 0 to 4, so D of 4 minus D of 0 over 4 minus 0. Our D of 4, the output value, oops, you couldn't see what I was doing, is 34 minus 25 over 4. What does it tell us? Show the computations that lead to your answer. Okay, these are computations. I see 9/4. Express your answer. Okay, so 9/4 is going to be, what is that, 2.25? Once again, do I put a 0? I don't know. They like 3 decimal places. Put it until I tell you otherwise. I don't like it. I think it's cumbersome, but it does answer the directions. Okay, use the average rate of change found in part B1, which is this, to estimate the total number of plays for the song at T equals 1.5. Okay, what I would do is I'm going to say the average rate of change is equal to D of 1.5 minus D of 0. I might as well, D of 0 is easier to work with, over 1.5 minus 0. Okay, so let's plug in what we know. We found an average rate of change. You know what? I'm going to hang on to the fraction. D, we don't know this. And I have seen pre-cal teachers do this a little bit differently. They come up with an equation, but it just doesn't make sense to me. I'm sorry. 1.5. And so we're solving for this. This just makes a ton of sense to me. Use the average rate of change and plug in for the unknown that we have. 1.5 times 9. What is that? 9 and then 4.5, so 13.5. This is 13. I was embarrassed to pull out my calculator for that. If I'm wrong, let's chalk it up to it's the end of May and I'm exhausted. Okay, and then I add 100. Okay, let's just verify. I'm pulling out my calculator. I can't even get to the right screen, you guys. Okay, here we go. So let's just make sure. 9 times 1.5. Yes, I was right. Add 100. Divide by 4. Okay, and so I find that my D of 1.5 should be approximately, the estimate using the average rate of change would be 28.375 thousand is what these things are. Show the work that leads to your answer. That would be my work. I think that would be good. Okay, so let A sub 1 represent the estimate of the total number of plays for the song in thousands using the average rate of change found in part B1. For A 1.5 found in part B, it can be shown that A.1.5 is less than D of 1.5. Okay, so they're saying this right here is A sub 1.5. All right. And we're saying that this is actually, so this A of 1.5 is equal to 28.375. And they're saying that this value is going to be less than the actual D of T. Okay. Explain why, in general, A of T is less than D of T for all, where T is between 0 and 4. Okay, So here's what's happening. We have our calculator. If we come back to this, we can come to our graph. Actually, I don't even need the graph. I noticed that my A value is negative. And so it's going to be concave down on its whole interval. And so it's, as I move, my average rate of change will be decreasing since it's concave down. I'll just type it in just for the fun of it. This is negative, that's not a negative button, oh my goodness. Negative 0.125 x squared plus 2.75 x plus 25. Okay, window, that's the standard window. Exit. What we really need to see is window. Let's go bigger, 30 here. Let's go higher, 30 here. I'm just guessing. Okay, and so what's happening from 0 to, actually, let's go a little higher. Window. Okay, so from 0 to G-solve, let's go find the y-calc when x equals 4. So they're asking us to look on this interval right here. Well, so the average rate of change through here is, because it's concave down, that line, and we could write we just found the slope of that line, okay, is 2.25 x, and then the intersection, what was that, was 25. Okay. I haven't done this before, y'all. This is fun. Okay, let me change my window. We're going to go from -2 to 6 and 20 to 40. That's not a 4. Okay, so you can see, because this is concave down, that line that we found the slope of that because we took the average rate of change between those 2 points. And then it was really convenient that they gave us the y-intercept. I could write the y equals mx plus b a lot more easily. And I went through there, and so it is the tangent line. I lied. The secant line, the secant line is below the curve. Okay, so explain your reasoning. Okay, so you would want to talk about the graph being concave down on that interval, and so the average rate of change is decreasing as you move down that interval that's concave down. Okay, let's see. The quadratic function model D has exactly, this is the last question here, has exactly one absolute minimum or one absolute maximum. That minimum or maximum can be used to determine a domain restriction for D. Okay. Based on the context of the problem, explain how that minimum or maximum can be used to determine a boundary for the domain of D. So let's come back to my window. What had I done? I did -10 to, was it 30 here, and then -10 to 50 here. I don't really need that line. Exit. Let's turn it off. Select, draw. Okay. So we're not going to ever lose views. You know, like the number of views on a particular video will only increase over time. It's not going to ever go down again. So if I do G-solve and find that maximum value at 11, what are my units? T equals 0 at time, T months. So 11 months later, this curve is no longer a valid model for our data. So let's see. Based on the context of the problem, explain how that minimum or maximum can be used to determine a boundary. Yeah, say something about the curve is increasing, but the number of views in the real world, you might get fewer views each month, but the total views that you have can't go down. If so, they're playing with the algorithm. No, I don't know. Anyway, I would answer something like that. Okay, let's see. This video, have we made it? We have made it through FRQ 1 and 2 with our calculator. I'm going to keep going. Here we go. Okay, that goes to the trash. That goes away. Now we're going to put away this calculator. Okay. Oh, this next one, it talks about a guitar string. As a cello player myself, I like strings that vibrate. Okay, for a guitar to make a sound, the string needs to vibrate or move up and down or back and forth in a motion that can be modeled by a periodic function. Okay, and this is the one, you guys, remember how they give us, they'll give us, pretend I can draw. And so they label this F, and they label the midline here G. They label this one J. Here's this one is K and P. Those are the letters that they like to use. There we go. Okay. At time t equals 0, point X on one vibrating guitar string starts at its highest position. Okay, so I would accept either of these as being 0, or you could, like this is the piece of the graph that they give you. There's no reason you can't back this up and find this over here as 0, except I didn't give you space. There's no stipulation that says that 0 has to be at F, or 0 has to be at P, or 0 can't be at an infinite number of places. Okay. At t equals 0, so I'm going to do this because that just seems to make sense. T equals 0. Point X on one vibrating string starts at its highest position, 2 millimeters above its resting position. Then it passes through its resting position and moves to its lowest point, 2 millimeters below its resting position. Point X then passes through its resting position and returns 2 millimeters above the resting position. This motion occurs 200 times in 1 second. 200 times per second. Okay, so that means it's going to do everything it's going to do by 1/200th of a second. Okay, so this would be times t equals 0. This would be t equals 1/200. Half of 200. To multiply this here, let's do this. 1/200. We're going to multiply this by, actually, we want to multiply it by 1/4. So this is going to be 1/800. So this next one here, G, is going to happen at t equals 1/800. And then this would be 2/800, which is, okay, what am I doing? I'm labeling it t equals 1/400. So 1/800, 2/800, 3/800. My brain just stopped. Because this is, 3/800 doesn't reduce. Okay, so this is t equals, I am in a bad way today. You guys, they shouldn't make me proctor this much. 3/800, 4/800 is 1/200. Okay, I have not labeled this very well. 5 points, determine the possible coordinates for the 5 points. Okay, so let's do that a little bit nicer. Okay, so what I would like to see if I were the grader is 0, comma, this is a positive 2. This would be 1/800, comma, 0. This would be 1/400, comma, -2. This would be 3/800, comma, what did we just say? 0. And this would be that's 1/200, comma, 2. That is what I would like to see. Okay, and so then we can write it as a function in terms of sine, okie dokie, h of t. The amplitude is 2. So here's what I would do. I don't know, were you able to write on this and stuff? If I had done it, okay, maybe I'll say this. So sine starts in the midline. Sine, if you make your a value positive, it goes up first. If you make your a value negative, you could go this way. I'll write a few examples. Maybe the first one I see is a positive 2 for an amplitude, sine. My b value, my period here, the period is equal to 2 pi over b. Well, the period was 1/200 is equal to 2 pi over b. And so multiply, cross multiply, b is equal to 400 pi. Okay, so 400 pi. So sine of 400 pi times t. Okay, so the first one that I see is that it's going to shift negative 3/800. And then we don't have to shift up because we were there at the midline. Another version, so maybe you wrote this one, negative 2 sine of 400 pi t minus 1/800. Close those parentheses. Maybe you wanted to back it up to here. And it would be positive a, that's what's positive. And then this, to shift it to the left, make that a plus. 1/800, close those parentheses. If you want to plug these into Desmos and plug in your answer and see if they match. Okay, then they said, well, do I have another color pen? Maybe. Then they said, look from G to J. So G to J is this little piece. And they're asking us about, okay, so from here to here. Notice that my output values they start 0 and they're negative. So the first question was, which of the following is true? Those values are negative and decreasing. So negative because they're below 0 and decreasing is how I see that. I'll be curious to find out this summer if they decided, if a student puts this as 0 and this is 2 and this is 4, would they allow for positive and decreasing? I think we're going to have to grade with. I at least hope we do, but I will find out this summer. Okay, so I said negative and decreasing, which is answer choice D. On that interval, describe the concavity and determine whether the rate of change is increasing or decreasing. The graph is concave up, so the rate of change is concave up, means increasing. Okay, we have done 3 out of 4. This is a long video, but you are holding strong. You're hanging with me. I'm not making as many stupid statements as I did. Okay, unless otherwise. Okay, so I see g of x. Oh, I can't use my pen. G of x is 2 log base 3 of x is equal to, they're saying make that equal to 4. Find all values in the domain of g. Okay, so we'll make sure we verify the domain in a second. I'm going to start by dividing by 2, and I have log base 3 of x equals 2, and I get 3 squared is equal to x. I think x is just equal to 9. Is 9 in the domain? Yes. Okay, let's see. If I had done this instead, if I had said log base 3 of x squared equals 4, then I have 3 to the 4th. 3 to the 4th is equal to x squared. 3 to the 4th, 3, 9, 27, 81. 81 equals x squared. If I said this and then I tried to do the cheer, square root, plus minus, and I say x is equal to plus or minus 9, when I plug in a negative here, it's no longer in my domain. Okay, so I would have to eliminate that anyway. So either method would be fine as long as you throw out that negative value, because that is not in the domain. Okay, if you, you wouldn't have been able to do this during the test, but if you go to Desmos and you graph this, well, it doesn't even matter what the base is. If you graph this, you will see that the domain of this graph is 0 to infinity. If you graph this, y is equal to log of x squared, you will see that the domain is different. The domain is, you still can't plug in 0 because you can't take the log of 0, but the domain would actually be this, which is kind of crazy. So these things are equivalent, and this graph matches with part of the domain here, but not the whole thing. Yeah, we should think through a little bit more why that's true, but in the meantime, okay. And then I have the next one says 4 cosine squared, I love trig, of x. Solve for that equals 3. Okie dokie. My kids, you should have found this easy. We've done so many of these. Cosine squared x equals 3 over 4, square root, plus minus. Cosine of x is equal to plus or minus root 3, square root of 4 is 2. Okay, we know the unit circle so very well. Cosine is the x value, so we went over a lot, or back a lot. And so this is the pi over 6 family. How did they answer the questions? Oh, they just said from 0 to pi over 2. So the only answer you need is that x equals pi over 6. I will be curious to find out if you write all 4, or if you write, if you don't do, when I was grading our practice ones, you guys, I only gave you credit if you said the exact right thing. So I'll be curious when we grade, because without the restriction, there's infinitely many answers. If you get to go from 0 to 2 pi, you got 4 answers, but they restricted you from 0 to pi over 2. Okay, I think that's all you can put. Okay, then the next one, I used too much paper. The next one says, write j as a single logarithm base 2. Okay, log base 2 of x plus 3 log base 2 of 2. Well, they want a single logarithm of base 2 without negative exponents in any part. Your result should be log base 2 of an expression. Okay, I see log base 2 of x plus log base 2 of 2 cubed, which is 8. I can squish these together with multiplication, log base 2 of 8x. I don't think you need parentheses, but if you do, you're fine. I would have written a harder problem. Y'all got lucky that I wasn't the writer. Okay, the next one, write k of x as an expression in which tangent, 6 over, so they gave us 6 over tangent of x times cosecant squared x minus 1. Okay, so what would I do with this problem? Well, I would have probably already written on my scratch paper, the Big Daddy. Go back and watch my other videos if you don't know what I'm talking about. And then I would have said, okay, how do I get cosecant? By dividing by sine squared. I don't know why I wrote a sine. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared is equal to cosecant squared. So then I can subtract 1. I get cotangent squared x is equal to cosecant squared x minus 1. So this right here is cotangent. Okie dokie. So this would be equivalent to 6. And I would, as a grader, I would want to see this and then the next step. And I mean, if you go this way, maybe that's okay. I don't know. But then I would say this is getting multiplied by cotangent squared of x. Well, tangent times cotangent. Or you could show me, I wouldn't require this step in my classroom, but I wouldn't count you wrong if you did it either. And so this, one of them is going to cancel the other, so I get 1 over tangent is cotangent. So I have 6. Well, 6 is being divided by 1 over tangent of x. So then I have to, I could say it this way, just I'm showing you every possible step you could possibly want. 6 is being divided by 1 over tangent. So then I'm going to keep change flip. This is 6 tangent x. Cool. That's tangent and nothing else. Fantastic. Okay. Oh, good. Here comes this last one. Find all values of the domain, the yield and output value. Okay, so it's e to the 2x minus e to the x minus 12, yield and output value of 0. Okay, what are we going to do? It starts with an f and ends in actor. We're going to factor. Or we could do a u substitution. We could say let u, not me, equal e to the x. And so this is e to the x squared minus e to the x minus 12 minus 0. So power to power, you multiply. And so I could rewrite this as u squared minus u minus 12. And now all of a sudden we're back in algebra 1. Okay, and so then I have u, and I need a negative 4, and I have u and a positive 3. Would factor. I double checked u squared. This is a positive 3u, a negative 4u gives me a negative, and that's, okay, that's 12. Yeah, negative 12. Okay, so u equals 4, or u, not me, equals negative 3. So what was u? Well, way back here, we said let u equal e to the x. E to the x equals 4. E to the x equals negative 3. Can we do this? No, we cannot. No matter what you do, if you have this positive number, it's about, 2.7. No matter what I raise it to, I'll never get a negative value. So I like to write nothing to see here. Because this part has no solution, but the whole problem does. And on this one, if e to the x equals 4, then we would say x equals the natural log of 4. We can verify this is e to the x equals 4. And that is in the domain, because the domain of the original function was all reals. You just can't find a value here. There, you can't take the natural log of negative 3. So, y'all, it took me 32 minutes to work the 4 FRQs. Did I write everything perfectly? Maybe not exactly. But if I were doing it and timing myself, I wouldn't have been talking as much. Okay, anyway, I hope that was helpful. Comment down below if you have any questions or suggestions or whatever. And like, subscribe, and go practice. All right, good luck to you.